5 to the 0 power, which is the same thing as 1. That's why anything raised to the 0 power actually equals 1. Here's fair warning. You've had 10 days off. This is a trick question. Five squared divided by 4 cubed. Which of these rules apply?
Neither.
None of them.
Neither. None. There's nothing you can do. You can write that it's 25 over 64 and call it a day.
Really?
Yeah, that's about it. And if these numbers are bigger, later on in the week, or before the next test, might be next week, I'll give you guys some idea of which numbers I would expect you to simplify like this and which you wouldn't. Basically, what I expect you to know. I think it's reasonable for me to expect you to know that 4 times 4 times 4 is 64, even without a calculator. I think it's reasonable for me to expect you to know that 5 squared is 25. I do not think it's reasonable for you to know what 5 to the 57th is. Okay? So if there's a non-calculator section on the next test, I will let you know how much mad multiplying you need to be able to do. All right, you ready for this to get weird?
No.
Good.
Isn't weird enough already.
No, it's not at all. If I have x cubed over x to the 9th, there are 2 ways to do this. One is the rule on the board, one I have not gone over.
Would it be a negative 6 then?
Yes, it would be x raised to the 3 minus 9, or x to the negative 6. Is there another way to express this?
No.
Yeah.
No.
Yeah.
If I'm asking a question like that, what do you think the answer is?
Yes.
Yes, there's another way to express this. I'm glad you asked, Nimi. Nimi is like the person a comedian plants in the audience to make sure that they yell the right things.
Oh, wait, I know. That's the...
There was so much snow last week, and then Nimi's the one who shouts, "How much snow was there?" Then I say something like, "There was so much snow, it was snow-overwhelming." I don't know. No. Yes, Jordan.
So that's the differentiation of 1,000 number go to the left instead of the right.
Correct. Correct. You're going to be great when we get to that. Okay. Now, here's another way to write this. Negative exponents are a weird idea. Okay? So are fractional exponents. We'll get to them a little later. But here's another way I could have worked this out. I could have written x times x times x. That's what x cubed actually means, right? Please tell me that I've been correct in assuming this. Okay. And then on the bottom, this means x times x times x times x times x times x, longer fraction, times x times x times x. 1, 2, 3, 1, 2, 3, 1, 2, 3. That's what x to the 9th actually means, right?
But you know you're not in
Am I not in the video? Amanda, can my cinematographer help me out here?
What? No, I mean like the board is, but like
But
you're
he's
not.
That's okay if I'm not.
Yeah,
The board
so?
should be. The board's more important. Okay, but thank you. Okay. Now, what is... Okay, when you're multiplying things top and bottom of a fraction, do you guys remember that you can always divide any factors
That are the same.
that are the same? Yeah, you can divide them.
Wouldn't you just
And
make
it's
it
actually
more
the same.
complicated than it already is instead of doing that to the negative 6?
Well, hold on a sec. That's why I make sure you guys... It depends on whether you remember a rule or not. But
More work.
bear with me a little bit. What's x divided by x?
1.
So that can basically go away because 1 times this fraction won't change it. 1 times anything stays the
So it's
same.
actually the same.
So what's x divided by x again?
1.
One more time?
It's still
1.
6.
Now what's left on the top?
0.
0.
No.
1.
1. These don't go away. You can always assume that there was a times 1 in there. In fact, you kind of have to assume there was a times 1 in there. The fact that you can multiply something times 1 and it doesn't change its value gets really useful now.
Then what's your point now?
Well, how many x's are left on the bottom?
6.
Right.
Okay, so this is the same as 1
1 over 6.
over x to the 6th. Did you guys remember that negative exponents mean you take the reciprocal? See, we just did this.
You don't have to do that. You can just flip it.
All right, pardon?
Mhm.
Yeah, we can just flip it. So if you get a negative exponent, it's the same thing as 1 over the positive exponent.
Because you cross the line.
Cross the line, change the sign is how Phil remembers it from his exceedingly clever prior algebra 2 teacher.
Yes. My 8th grade teacher.
So
Miss Stevens.
here's a fun bit of trivia, okay? In every math book I've ever seen, and every teacher I've ever had, This is not considered simplest form. You're expected to get rid of any negative exponents and make them positive exponents by flipping them to the other side of a fraction mark. Okay? However, just so you know, on certain standardized tests, this will appear in some of the answers. So,
If we
good luck with that.
If we were to have it on a test and we simplified it to like x negative 6, could we keep it that way?
For my tests, I'm going to say simplest form is no negative exponents.
Are you gonna return the test?
Yeah, I will, if we have time, which we should. Okay, so that's all the division stuff. Time to erase this rule, go on to the next one.
How many rules are there?
Well, we're really going to concentrate on 3 today, and then we're going to see how many hideous examples of how they all mix and match we can find.
Or we could just start on a homework.
No, not yet.
Or you
Almost.
could return the test.
Slow down, guys. All right, a number is raised to a power, and then that whole expression is raised to another power. Now what do you do?
Oh, times the exponents.
Times the exponents.
I hate these.
Okay, so if I have, for an example, 5 to the 5th power, and I decide to raise that to the 3rd
So
power.
it'd be 5 to the 15th.
5 to the 15th. Very good. Okay. You guys ready for me to start mixing and matching all of these rules?
Sure.
Okay. Start with an example over here. How bad should I make the first one?
Hard. Easy.
The first one easy, okay.
Okay, you never should be putting x and y's in there.
Oh. I'm totally putting X and Y's in there.
What the heck?
That's easy.
Oh,
Not even in there.
Okay.
Oh, I'll do it.
Get this expression in simplest form. Now, there's one thing I did not mention yet. Okay? What does it mean when I have 3 things being multiplied in here and they're all being raised to a power?
What do you mean?
You raise each individual one to the power.
Raise each individual one to the power. So my first step is going to be, this is going to be 5 squared, then x squared squared, then y to the 3rd power
Well,
squared.
no, wouldn't it just be
4?
Hold on, I want to hear Jordan's question.
wouldn't it just be 14?
No.
X y 14?
no.
Wait, that's not
No. Okay, you can't
Yeah, I got it.
you can't multiply these exponents together.
We can use that again. So would it be
Okay, hold on. If you have multiple things being multiplied together, I use the word multiple too many times there. If you have 3 different factors in here, that's things being multiplied, okay? And they're in parentheses and there's an exponent on the outside. You raise each factor on the inside to that power. It's a little bit like distributing, but this doesn't work with addition and subtraction. It only works if it's all being multiplied. Yes?
I have a question. So would your answer be 1x to the 3rd and y to the 5th?
Hold on. I'll find out in a moment. I think so. I think you may have left out something.
I'm going to do 1 squared. No.
Hold on, Mimi. Hold on. Okay. I'm going to leave the 5 squared as 5 squared. What is x squared raised to the 2nd power based on this rule? X to the 4th. What is y cubed raised to the 2nd power? Y to the 6th. Good. And I haven't touched the 5xy on the bottom. If you don't see an exponent on a number or an x or a y, what do you assume is there?
1.
1.
My,
No, we should get your big phone finger.
Wait, why is y 6?
Y6, okay. We have y cubed to the 3rd power, and then we're raising that to the 2nd power. So when you're raising a power to a power, you multiply the exponents. Yasmin.
For the first part, why did, okay, you had x in parentheses, x squared in parentheses,
Yes.
and then you squared that again.
Okay, this squared applies to everything in the parentheses, each one separately. Again, that's a rule that only works when everything in the parentheses is being multiplied. If there's addition in the parentheses, well, I'll show you that in a second. Okay, 5 squared. Now, here's where you can separate them into like terms. And here like terms means which of these exponents in here all have the same base. 5 lines up with 5, the x with the x, the y with the y.
Then we can subtract.
Subtract the exponents? Yes.
That's what I thought.
Okay, so 5 squared divided by 5 to the 1st gives me
5.
5.
x to the 4th divided by